The fourth topic we're going to discuss in category 1 is exponents. These are the ones that we tied colored laws to. So the first law we studied was the multiplication law, or the product law, that says when you multiply exponentials with like bases, you can add exponents. And we proved why that was. And then the quotient law, or division law, said with like bases in dividing, we can simply subtract exponents. The power law, inner exponent raised to an outer exponent, we can simply multiply exponents. And remember, the base has to be a single term or a monomial. Rational exponent, remember we did base raised to the power divided by index. So we took the inner exponent and divided it by the index. And the last law we looked at was the negative law, which was the unhappy cow. And on that one we thought about move, right? We moved the cow across the fence line to greener pastures. And then the other thing was the law of zero. You might want to jot that one down. That just simply said any base raised to the zero power is 1. So I'm not going to do all these, but I'll get you started and I'll let you practice these laws of exponents. The first one, I'm going to identify what color laws we would need. So in the numerator, when I see two sets of parentheses side by side, I know this is the product law. So this one once again states we're going to multiply exponentials with like bases, we can add exponents. So after I simplify that numerator, I'm going to come back and then use the division law, or the blue law, that says when we divide, we subtract exponents. Now remember, we still treat these leading coefficients or numbers the same. So if I'm looking at this, I would say 4 times 7. I would multiply my two leading coefficients. Then I would look at x, doesn't have an exponent, so I know it's an understood 1, times x squared. Then I would look at my like bases of y to the 9th, times y 12th, and then z to the negative 3 times z to the positive 3. So I could simplify by saying 4 times 7 is 28. Like bases, with my x's, I can add exponents. So 1 plus 2, x to the 3rd. 9 plus 12, because my bases are both y, I get y to the 21st. Negative 3 plus 3 gives me 0, so I'm still going to write z to the 0. So now my numerator is completely multiplied. The last thing you will need to do on this is divide by 12, x to the 6th, y to the 4th, z to the negative 2. And once again, the division law states when dividing exponentials with like bases, we can subtract exponents. And be careful when you simplify this one. When you subtract exponents, I think you're going to have one unhappy cow. The last thing I want to say is 28 divided by 12. You simply need to simplify that fraction because we know that 12 does not divide into 28 evenly. So you should be thinking, what is the largest number divided into 28 and 12? Looking at the second one, we have the, looks like power law, because we have inner exponents, and this is a single term because it's a product of numbers and variables. That's how we define a monomial, is a number, a variable, or the product. So we have all these numbers and variables pushed together. So we would simply say on power law, I would say 64 to the 1st has an understood 1 times a to the 6th times b to the 3rd. All of this is being raised to the 1/3. So remember on power law, we would simply multiply inner exponents times outer. So you would say 64, 1 times 1/3 is 1/3. On the A, 6 times 1/3 is positive 2. And then 3 times 1/3, 3 times 1/3 is 1. So the only thing we'd want to simplify is this first number, and you could simply type that in your calculator. Remember 64 caret top 1/3. The last one is giving us a square, and it tells us that the area, this should say area instead of side, the area is 49 x to the 6 y to the 10. So it wants us to find, well, what is this side length of the square? We know all sides are the same. So remember, to find area of a square, we do A equals S squared, or S times S. So all I've done is plug in the area of the square that was given to us, and that's equal to S squared. Now I don't want to solve for S squared, I just want one side length. So all we have to do here to solve for S is take the square root of both sides. So that would give me S equals, now the square root, so there's my index, 49 to the first, x to the sixth, y to the 10th. Now all you need to do on this one is go up and apply base raised to the power divided by index. So I would take the base, well my first base is 49 under the square root. So I would say 49 raised to the power, well its power is 1, divided by its a square root, so the index is 2. So 49 to the 1/2. X is my next base, raised to the 6, divided by the index is 2, and then y raised to its power of 10, divided by the index of 2. And you could simplify that.